Welcome back to today's segment of Elite Page DIY Guide. Today we shall be considering an important subject matter and the tagged 7-segment display. Have you ever been to a fuel station before? Have you ever turned on your AC and you're trying to regulate the temperature? You would notice the importance of this 7-segment display. Let's get right into it. A 7-segment can either be common cathode or common anode. Anode meaning positive, cathode meaning negative. That is, having common negative. As we all know, what is present in this particular 7-segment display is actually an array of LEDs, that's light emitting diode. And every light emitting diode has the anode and the cathode. The anode is a positive probe, while the cathode is a negative probe. Sometimes you can actually have something like this, which is a cascaded 7-segment display. Let's dive deeper into this theorem. Okay, yes, so we want to actually check if it's actually common cathode or common anode. Let's say, for instance, on my breadboard here, I try to impute this particular entity here. 3 things I'm going to be determining here. Number 1 is to determine if it is common anode or common cathode. Now, let's say I resist this, which is actually connected to my to my ground. I put it here on this rail. Then I try to kind of like supply any one of these. That is, I just try to put this here to determine if it's actually common cathode or common anode. Then I just try to kind of like move across board to check if any of these segments is going to turn on. So upon not having to see anyone turn on, that's to tell you that I need to actually interchange. Now let me just try to interchange now. Make this a constant while this becomes a what? A variable. Then I just try to kind of like move across board to see if it turns on at any point in time. Now looking at this now, this actually definitely gets turned on at the moment. That means if I should move further, nothing turns on again. That means this particular pin here should be a constant. So then the next thing is now I'll now try to navigate across board. As you can actually see that this is A, B, C, D, E, F and G. So we keep moving and we'll keep labeling. This is actually our our F. Then we'll move further. This is actually our G. Then we'll come here. This is actually our decimal point. Then you move to this place as well. Our D comes on. Then our E comes on. Having to check, this is actually negatively charged. You should check based on your connection. Then this particular entity that actually goes across board. So let's just try to proceed further by having to label this. Okay, yes, so basically we have 10 pins. 1, 2, 3, 4, and 5. Then at this point in time, we have another 8 to the lower part of it. 1, 2, 3, 4, 5. In comparison with this other bit here, you have it to be 1, 2. That's at the reverse side of this particular 7-segment display. You have 1, 2, 3, 4, 5, 6. 6 at the top, 6 at the bottom as well. And this is actually meant to produce 4 7-segment display that has actually been cascaded and 4 decimal points. Now we get on to label. Now at the top, having to note that this particular entity at the middle here is actually what? The common cathode. Most times, whenever you have common cathode this way, you may also have another one at the reverse side based on designs. Now, let's just try to move. As you can see, to this side of it, that's the last one. You have this to be our what? Our E. Then we proceed to the next one, which is our what? Our D. We proceed to the next one after this. That gives us our what? Our C. As you all know, this is A, B, C, D, E, F, and G. So that's just pretty much it as regards that bit. Yeah, so we've been able to label this. Then we'll move further. We have something like this, actually our decimal points. Then we'll proceed further to actually just try to inspect the upper layer. So we have this one to be our B. This other bit here is our A. If we should power this here now, nothing comes on. That means they are both common. If I should interchange this from being this point now and I put it here, it's going to act as a common as well. Let's just try to check, as you can see. So that means it actually gets interchanged upon you having to kind of like what, move to the other part of this segment. So you have this other bit as well. So this is A. Then you move to the left hand side of it, you have F. And as we've actually demonstrated the other time, that this is actually also a what? A common cathode as well. Then we move here, then you have your what? You have your G. Now the next thing we want to do is to jump right into our code, and I'll be sharing my screen at this point in time. We're using Arduino IDE. IDE meaning Integrated Development Environment. So we're going to be launching our Arduino IDE now. Okay, yes, so upon launching our Arduino IDE, we're going to see something like this: void setup and void loop. First thing first we want to do is to actually define some variables. But at this point in time, they will definitely be constant. So I'm going to have constant int A equals to, depending on the pin I want to use. Let's say for instance, I want to use 2. So equals to what? 2. Then I have the next one, constant int B equals to 3. On and on and on and on like that. So then I continue that way. The next thing is actually to send my pin mode. Without having to take much of our time, so having written our code, you're going to have something like this, and we have different sections of the codes. Let's say for instance now, you can see something like 0 like this. You have 0. This A, B, C, D, E, F. So as you can see here now, that's A, B, C, D to F, they are all high. But this G is definitely going to be low. Let's look at 1. A is low, that is to say the the segment A is meant to be turned off. Then you have something like this, B and C to be turned on. And that's why you have something like this here. Then let's move on towards the section 2. You have something like this, A is on, as you can see. B is on. C is low, that means you don't have anything here. D is high, as you can see at this point in time. Then your E is also high. Then you have your what? Your F is definitely going to be low. Then you have your G. So you can see that 2 is actually being written at this point in time. Then move on to the next one, 3. A is high. B is high. C is high. D is high. Then G is high. As you can see that E and F, they are definitely low. That is to say, they are not meant to be turned on. Then let's look at 4. A, for you to write 4 will be low. B, high. C, high. As you can see on your screen at this point in time, that is to say, for you to write 4, B is high, C is high, then D is low, which is actually D. That means it's not meant to be on. Now, let's take for instance 4. A is low, that is, it's turned off. B is high. C is high, D is low, E is low, but F will be high. As you can see at this point in time, then your G will be what? High as well. Let's look at 5. A will be high, as you can see on your screen. B is low, C is high, A is high, B is low, C is high, D is high, E is definitely going to be low, as you can see on your screen at this point in time. F is high, then your G is what? High. Let's look at 6 for instance. You can see that A is high, B is low, C is high, as you can see at this point in time for 6. D is high, E is high, F is high, and what? G is high. Let's look at 7 for instance. You have 7 to what? A is high, B is high, and C is also what? High, as you can see at this point in time. But when you look at 8 now, everything is definitely going to be high. A, B, C, D, E, F, G. Then you have something like this here, 9. That is to say, A is high, B is high, C is high, D is high, then E is low, F is high, and G is what? Low, definitely. So we've written 0 to 9. So the next thing we're going to do is to just get these bonds onto our what? Onto our Arduino board. But prior to having to bond it, we might want to do some pin-out connections. Having to use this jumper wire at this point in time. So you might just want to do well to actually follow me as I actually proceed with this. Let's just try to connect. A, having defined it that A is 2, so we just try to remove this particular entity here, which was just being used to determine if it's actually common cathode or common anode. They will just try to put this here at this point in time now. So let's just try to have it this way. So let's say this is A, B, C. So let's come here this way now. This is our A, which is this particular entity here, connected to pin 2 on your Arduino. Then I bring it here. This is our A, based on what we actually figured out here. This is our A, so that means this particular entity, it actually comes here. Then we have our B to follow. We just try to connect this at this point in time here. I put it here. This is our B. Then C follows suit. This is our C, which is actually pin 4 based on the way it's actually been arranged on your screen here. Then what's the next one? Okay, I've actually connected this. Then let me try to locate my C. My C is definitely somewhere here. D, which is actually the next one, connected to what? Pin 5 on my Arduino board. So my D, where is my D here? My D is actually here. E, which is actually the next one to it, it's connected as well. My E, I connect it here, then I come here to actually just try to insert it here as well. F, so you might just want to do well to actually follow the exact way it's being wired so that your code will actually work accordingly. So I have my F in here, which is actually this F, which is actually pin 7. Going by this my schematic I actually drew here, my F is somewhere here. Then I have my what? My G, which is actually pin 8. Then I just try to connect this here. So the next thing I want to do is to actually bond this to my what? Arduino board. So I just have to have something like this. Then I select the USB connection, that's the USB serial. Then I just try to select Arduino Uno as a result of my having to use MacBook. But if you're using other operating systems, you might, it's just a plug and play. But based on the popularity of this, I might need to select the type of board at any point in time. I actually just try to connect this. So it's currently compiling Sketch, as you can see on my screen. Then the next thing is it's done. So it's currently uploading. So you can see now 0, 1, 2, 3. As you can see on my screen at this point in time, that is actually counting. Now here is it basically. You can actually notice that the delay here 0, 2000 milliseconds, that's actually 2 seconds, 1, like that. So what I just want to do to make it faster is just to, let's say we just want to kind of like change it to every 1 second, you should just try to change. So now so I just have something like this, 1, then I change every bit of this to whatever, so you can make it faster. But in a situation whereby I don't really want to stress myself having to kind of like at that point in time, whenever I want to change the delay, I need to type 222 on every one. So what I might just do is that I might just try to write a particular method, void, let's say DLY, void delay. Then I have something like this. Then whatever the delay is meant to be, I just need to send it. So let's just try to make it more object oriented. So what I might just want to do is just to define the delay as just one particular entity. I'll just say constant int DLLY, just define it somewhere. Then I have something like this. I'll say constant in DLLY equals to, let me say, 500. That's actually half of a second, definitely. So let's see how fast it's going to be. 500 milliseconds. So I have something like this. Then the next thing is, I'll just keep calling this DLLY at different point in time, instead of having to, for every succession, I'll just call DLY. So let's just try to see this, how it's going to come into play now. So I'll just try to place this here. So I'll place that instead of having to have 2000 milliseconds at every point in time being written, I just need to change the particular variable or the constant at one point, then it actually applies to everything, so it just make it uniform. So this is just to make sure that our code is actually object oriented to a reasonable extent, so that we don't really need to stress ourselves in being able to adjust the parameters. So let's try to proceed further. So I have something like this. So let's see. So I have something like, so let's try to burn it now. So let's try to kind of like just try to compile our code now, so we can see that it's currently running. So let's see how fast this is going to be. You can see 0, 1, 2, 3, 4. So as you can see on my body that it's currently faster than how it used to be. So let's just try to say, for instance, you go to a filling station and how the stuff is actually moving and all that. Maybe you want to just have something very, very fast as that of filling station. Let's say you have something like, let's say 200 milliseconds. Let's see what happens, how fast it's going to be. So let's see what happens now. 1, 2, 3, 4, 5. So you can see it's definitely faster. So that's just pretty much it. On our next episode on DIY guide, we're going to be dating our hands with 7-segment display that is cascaded this way, which is very much similar to what you have in your fuel station, that actually measures the volume of fuel that flows into your gallon or into your car. And we're going to be counting from 0 to 9,999. The code is always available on your EliteReach app or the app customized for your school. Do well to actually get your hands dirty with this. See you in the next episode. I remain your amazing host, Akin Adinka. Bye for now.